Everyone, in this video I am going to begin reaction mechanism. In this reaction mechanism we will learn bond cleavage and types of attacking reagents and reaction intermediates, electron displacement effects. These four will be discussed in reaction mechanism part 1. So reaction mechanism part 1 takes some series of videos. So this is beginning video. First of all, what is reaction mechanism? The sequential account of each step for a reaction. All steps are sequential account of each step involving the details of bond cleavage, describing the details of bond cleavage, electron movement during bond cleavage and bond formation, and energetics during bond formation and bond cleavage, and rate of transformation of reactants into products. What is the reaction mechanism? Reaction mechanism is the sequential account of each step, describing the details of electron movement and energetic during formation of bond and during cleavage of bond, how energy changed, and rate of transformation of reactants into product, how much time the reaction will take to complete the reaction, in how much time the reactants are converted to product, that is kinetics. Rate of reaction will also be discussed in reaction mechanism. So in reaction mechanism all these details will be discussed. What are the details will be discussed? Details of electron movement and energetics during bond cleavage and bond formation, how energy change takes place during bond cleavage and bond formation, and transformation, rate of transformation of reactants into products. All this is referred to as reaction mechanism. So in a general reaction mechanism, this is some chemical reaction. For this chemical reaction R with some living groups. So plus G, these two comes under reactants. RL and G both comes under reactant. So during this reaction what happens? Here living group go out and incoming attacking group attack on this R. It gives some transition state or maybe intermediate, both are different. So finally G form a new bond with R and L comes out. So RG and L are said to be products, here RL and G are said to be reactant, and this is some transition, some intermediate state or transition state. Transition, the main difference between transition state and intermediate state is, transition state is hypothetical one which cannot be isolated, but intermediate is isolable. Intermediate has own existence, we can separate it from the reaction mixture, that is the difference. So in reactant, one is said to be substrate, other is said to be attacking reagent. So what is substrate? Substrate is reagent. What is substrate? Substrate is reactant. Substrate is reactant. Substrate is reactant which provide carbon, which provides carbon for new bond formation. For formation of new bond, substrate provide carbon atom. What is attacking reagent? Attacking reagent or simply reagent is reactant. It is also reactant. Both are reactant. Substrate and attacking reagent both are reactants which form a new bond. Which form a new bond with carbon atom of substrate. with carbon atom of substrate. With carbon atom of substrate. Thus, a chemical reaction takes place. Okay, of course, transition state has greater energy than, for example, this is energy, and this is reaction coordinate. So reactant's energy is here, transition energy or intermediate state energy is here, transition state or intermediate, and finally product, or otherwise like this: energy on y-axis, reaction coordinate on x-axis. If I take like this, reactant energy is this one and product energy is this one. This is transition state or intermediate. If you compare here, reactant energy, product energy, here reactant energy lesser than product, here reactant energy is greater than product. So whenever reactant energy lesser than product, that is called endothermic reaction. Whenever reactant energy greater than product, that is called exothermic reaction. Why? Because product energy greater mean, so from reactants only products are formed. The extra energy gained or supplied by us. Reactants, while reactants are converted to product, how products gain energy? Some of the energy from the reactant, remaining energy is supplied by us. So energy absorbed by the reaction. If product energy greater than reactant, that is endothermic reaction. If reactant energy greater than product, so product have less energy means remaining energy released to atmosphere, released to surroundings. So that is called exothermic reaction, endothermic and exothermic reaction. So thus reaction mechanism deals energetics during bond formation and bond cleavage also. Okay, take this one. Next, reaction mechanism is the biggest part that I divided into two parts: reaction mechanism 1, reaction mechanism 2. In reaction mechanism 1, we are going to learn, in part 1, we are going to learn bond cleavage, types of bond cleavage. Second one, attacking reagents. These are subtopics. Next, thirdly, electron displacement effects. Fourthly, reaction intermediates. There are 4 parts in this in that first one is bond cleavage. Bond cleavage. What is bond cleavage? Breaking of bond is nothing but bond cleavage. Okay, so chemical reactions involve cleavage of bonds, cleavage of old bonds and formation of new bonds. In general, chemical reactions involve what is chemical reaction? Chemical reaction involves cleavage of old bonds, cleavage of old bonds. Chemical reaction involves cleavage of old bonds and formation of new bonds. Cleavage of old bonds and formation of new bonds. Cleavage of old bonds and formation of new bonds. Okay. So if you see cleavage of bonds, there are two different type of bond cleavage is observed. There are two different types of bond cleavage. Bond cleavage. There are two different types of bond cleavage. Homolysis and heterolysis. They are bond cleavages are two types. They are, one is homolysis. Homolysis, this is also called as homolytic bond cleavage. Homolysis is also said to be homolytic bond cleavage. Homolytic bond cleavage. And the second one is heterolysis. Heterolysis, it is also said to be heterolytic bond cleavage. Homolytic bond cleavage, I will explain separately. Heterolytic bond cleavage. Homolytic bond cleavage and heterolytic bond cleavage. Okay, take this one, I will explain what is the homolytic bond cleavage. Let's see what is homolysis. Homolysis is when a bond cleavage takes place symmetrically. Symmetrically means equal distribution on both sides. When a bond cleavage takes place symmetrically, it is said to be homolysis. That is considered to be homolysis or homolytic bond cleavage. Both in homolysis, both bonded atoms are separated with one electron. So if a bond is present between two atoms, both are separated with one electron. Bond cleavage takes place symmetrically. One takes one electron, other takes one electron. Because a bond is made up of two electrons, both bonded atom takes one electron each. Thus bond cleavage takes place symmetrically. So homolysis results in free radical. Homolysis denoted with a pair of half hook arrows like this. So here carbon takes one electron, half hook. So this is half hook. Curved half hook. A pair of curved half hooks. A pair of curved half hooks. A pair of curved half hook arrows. A pair of curved half hook arrows. So one is like this, other is a curved other head, only one head, half hook. Here curved arrow, only one head. That means, so here carbon has getting one electron, X getting one electron. This type of cleavage takes place if electronegativity difference is almost similar or lesser than 2. Electronegativity difference must be lesser than 2, almost similar. Electronegativity difference between C and X is electronegativity difference between C and X is lesser value. That is electronegativity difference between two must be 2. Electronegativity difference must be lesser than 2. Due to presence of unpaired electron, here homolysis results free radical. These are free radical. Free radical mean a species contain odd number of electron. So unpaired electron. So due to presence of unpaired electron, free radicals are unstable. So if electrons are paired up, that is stable. If electron is unpaired, that species is unstable, more reactive. Due to presence of unpaired electron, free radicals are less stable and more reactive. Less stable in the sense, more reactive. Next, homolysis takes place in non-polar bonds. So polar bonds means electronegativity difference is large. Non-polar bonds means electronegativity difference is small. Next, to occur homolysis, electronegativity difference between two bonded atoms must be lesser than 2. That is I am telling. Non-polar bond electronegativity difference must be lesser than 2. Next, homolysis is favored by presence of free radical initiators. Homolysis is favored by presence of free radical initiators like high temperature or UV light, or otherwise peroxide, non-polar solvents, and gaseous phase also, reactant in gaseous phase. All these conditions favorable for free radical production. Free radical initiators favors homolytic bond cleavage. Okay, so take this one. I will explain what are non-polar solvents. Non-polar solvents means there is no polarity in those solvents because of non-polar bonds are present. Non-polar bonds in the sense electronegativity difference between bonded atoms is very less. Such solvents are called non-polar solvents. Carbon tetrachloride, carbon disulfide, benzene, N-hexane, N-heptane, cyclooctane, like that. Okay, so I will give example. Take this one. Let's see examples of non-polar solvents: carbon tetrachloride, carbon disulfide, benzene, mescaline, 1,3,5 trimethyl benzene, toluene, methyl benzene, N-hexane, N-heptane, cyclohexane, etc. So mostly hydrocarbon because carbon hydrogen electronegativity just 0.5. Carbon chlorine electronegativity different, carbon sulfur electronegativity different, carbon hydrogen electronegativity difference is less. That's why all these are non-polar solvents. So in non-polar solvents generally homolytic bond cleavage is favorable. Next, heterolysis. When a bond cleaves unsymmetrically, that is said to be heterolysis or heterolytic bond cleavage. Next, heterolytic bond cleavage resulting ions. One positive charged ion, one negative charged ions. Next, heterolysis is favored by polar solvents. Homolysis favored by non-polar solvents. Heterolysis favored by polar solvents. Okay, polar solvents two types: polar protic solvents, polar aprotic solvents. I will explain later. Next, low temperature. Homolysis favored by high temperature, presence of UV light, but heterolysis favored by low temperature. Heterolysis usually takes place in polar bonds. Polar bond mean electronegativity difference is greater than 2. In such bonds only heterolytic bond cleavage takes place. Heterolysis denoted with curved arrow. So see, if X is greater than, electronegativity of X is greater than C. So that means X is more electronegative than C, then bond cleavage takes place like this. So what is electronegativity? The tendency to gain bond pair electron towards itself. So X takes away electron, X become minus due to loss of electrons. See, this bond takes place like this. One bond belongs to carbon, one electron belongs to carbon, other electron belongs to X. Here X going out along with carbon electron also. This electron belongs to actually carbon. Here carbon loss electron getting positive charge. Here along with its electron, here X gaining one more electron. Due to gaining of electron, X acquire negative charge. So positive ion, negative ion. If C is greater than X, then C takes both bond pair electron. Then C become negative, X become positive. Okay. So this is homolysis and heterolysis. Take this one, I will give examples of polar solvents. Polar solvents. For non-polar solvents, dipole moment is 0. There is no polarity. For polar solvents, dipole moment is not equals to 0. They have some polarity in their bonds. Polar solvents are two types. They are polar protic solvents, polar aprotic solvents. Polar protic solvents, they produce H plus ion. Protic, they produce H plus ion. To produce H plus ion, hydrogen must be attached with more electronegative atom like halogen, oxygen, nitrogen. That means hydrogen must be attached with more electronegative atom. Then more electronegative atoms takes bond pair, hydrogen released as H plus ion. Polar protic solvents produce H plus ion. Like water. In water, OH bond is there. In ethyl alcohol, OH bond. Methyl alcohol, OH bond. Isopropyl alcohol, OH bond. Acetic acid, OH bond. NH3, ammonia, NH bond. Hydrogen fluoride, HF bond. All these are polar bonds. Okay, they produce H plus ion. They are polar and produce H plus ion. Polar protic solvent. Second category, polar aprotic solvents. They are polar, they have polar bond, but they do not produce H plus ion because hydrogen not attached to more electronegative atom. This is polar bond but not protic, and this is SO bond is polar but not protic. Here CO bond polar but not protic. So here hydrogen, always hydrogen attached with carbon, hydrogen attached with carbon. See, carbon electronegativity is 2.5, hydrogen electronegativity is 2.0. So there is no much electronegativity difference. This electronegativity difference is not sufficient to make the bond between carbon and hydrogen. This bond is not polar bond. That's why H plus ion production is not possible. That's why, so here always hydrogen attached with carbon, hydrogen not attached with nitrogen, halogen or oxygen. That's why all these are polar but do not produce H plus ion. Polar aprotic solvents. Polar protic solvents. Polar aprotic solvents. Okay, take this one.